Welcome to the educational module Introduction to the Internet of Things of SendingVet program. The current section introduces you to the IoT device itself. It presents a conceptual stack architectural layer of the device and specific management procedures to ensure that all its functionality is fully exploited from the time of the deployment up until it's decommissioned. The current section introduces a conceptual architecture of the device and briefly describes management procedures to ensure full device functionality. IoT device architecture. The IoT device architecture consists of 4 layers: the communication layer, the hardware abstraction layer, the operating system layer, and the remote management layer. Starting from the bottom up of IoT architecture, there is the operating system layer. The operating system is the connection between the software and hardware. This layer consists of many IoT devices that run bare metal firmware and RTOS like Mbed and FreeRTOS, Contiki, TinyOS. The second layer is the hardware abstraction, is the layer that provides access to the hardware features, such as the MCU, flash, GPIO, serial interfaces, etc. The third layer is the communication support layer that consists of wired and wireless protocols based on the deployment of the IoT device. An IoT device can use a communication protocol such as Bluetooth, Z-Wave, Zigbee, Thread, etc. The last layer, which is applied to all other layers, is the remote management layer. The remote management layer ensures that the hardware manufacturer and software developer can monitor the device and upgrade the firmware. The firmware to be updated may be the operating system and/or communication layer. Device management. To ensure that the IoT device's functionality works as intended throughout its lifetime, certain management procedures need to be applied, because it is not enough to just install it and let things go their way. These connected devices require some procedures in order to manage their performance to ensure the following: facilitate the interaction between them, ensure secure data transmission, and more. These procedures are: device identification, configuration and control, monitoring and diagnostics, software updates and maintenance. Device identification. The device identification is responsible to establish the identity of the device. This is done in order to ensure that the device is genuine with trusted software transmitting reliable data. Configuration and control. Configuration and control procedure is responsible to tune devices according to the purposes of an IoT system. When a device is installed, some parameters are needed to be written or updates might be needed. Some parameters need to be written once a device is installed, for example, unique device ID. Other settings might need updates, for example, the time between sending messages with data. Monitoring and diagnostics. Monitoring and diagnostics procedure ensures smooth and secure performance of every device in the network, as well as it reduces the risk of breakdowns. Software updates and maintenance. The software updates and maintenance procedure is responsible to add functionality, fix bugs, address security vulnerabilities. In this module we have introduced the general IoT device architecture and management procedures of the IoT device. The main conclusion is that the IoT device should always be monitored by authorized interested stakeholders throughout its lifetime. This concludes our presentation on the IoT device architecture and management.